What is death in the wide night? For stone and ice and dust, stars end in fire and collapse, worlds cool into silence and shadow. Comets end by losing themselves, their shapes unspooling into clouds. 3i Atlas teaches this already. Mortality belongs to matter itself. Cracks open under sunlight and cold, volatiles flee through narrow vents, spin grows faster as weight is shed, structure yields to the growing strain. A body becomes many bodies, a path becomes many paths. Endings look like dispersion here, not a stop but a passing through. What is carried into that passing? Chemistry stored since older suns. Dust holds messages without words, ratios and chains and fragile bonds. A death can also be a harvest, a release of memory into space. 3i Atlas breaks apart before us, and the lesson is not empty. We watch, we measure, we learn how things end, and how endings become seeds. The dome turned slowly under a quiet night. Mirrors cooled, air steadied, stars fixed in place. The routine was ordinary, the track list precise. 3i Atlas appeared in the frame again, a faint visitor moving fast, unbound by the sun. At first the image looked calm, a soft core, a short trail of haze, nothing unusual at sight. Then the second stack arrived and unease began. The bright centre no longer held one peak. It fluttered, split, dimmed, returned blurred. An assistant leaned forward, checked alignments, subtracted stars, stretched contrast carefully. Another light detached from the core, a small pointer trailing faint behind, then another, smaller still, drifting farther. The voice on the channel stayed steady, but hands shook over keys. By midnight the network hummed alive, Hawaii, Chile, Canary sites compared frames. We confirm, they said, fragments are real. Logs filled with new labels, A, B, C. Atlas was no longer one, but many. Light curves began to fall in steps. Brightness dropped with each separation. Dust thickened around weaker heads, a haze of death around the broken body. Hubble received the urgent request. By dawn its eye captured the ruin. Sharp images showed shards spread apart, the parent fading, the child lights trailing. The word death entered quiet notes. Not speculation, not metaphor, but observation written in graphs. A comet was dying before our eyes, not in myth, but in present time. Phones lit with questions of danger. Could fragments fall toward Earth? Teams replied with steady patience. Earth remained safe by present models, yet fear moved faster than numbers. At sunrise, the dome fell still. Data saved. Fragments logged. Witness to an ending complete. 3i Atlas was unravelling now, its body breaking night after night. The chapter closes in us, not conclusion, but recognition. The next chapter will ask the causes. Why comets die, why stone and ice cannot endure. 3i Atlas no longer travelled whole. Fragments drifted behind the weakening core. Dust veils expanded in uneven haze. Astronomy turned from discovery to diagnosis. The question was simple in form. Why do comets die? The body of a comet is fragile, stone mixed with ice, carbon chains bound with dust. Not solid like rock, but porous like frozen sponge. Sunlight awakens hidden stress inside. Heat expands trapped volatiles. Cold fractures brittle crust. Spin increases as jets erupt. Together these forces unmake the body. Thermal stress is first suspect. Comets formed in cold deep. When they near the sun, their outer shell warms unevenly. One side cracks while the other contracts. Stress lines spread through weak layers. Fractures widen with each orbit. Small breaks grow to great wounds. Atlas showed this pattern in brightness. Light curves dropped sharply at intervals. Each drop aligned with a new fragment. The comet was tearing along hidden seams. Sublimation is the second suspect. Volatiles like carbon dioxide and carbon monoxide turn to gas near the sun. Jets erupt from surface vents, carving tunnels and hollowing chambers. Pressure builds in cavities until they fail. The roof collapses, the core splits. Atlas revealed jets in narrow streams. Dust production was irregular but strong. These bursts pushed fragments outward. changing both brightness and shape. Spin-up is third suspect. When jets erupt unevenly, they impart torque on body, rotation quickens, centrifugal stress increases. If rotation exceeds structural strength, the comet flies apart. This is called rotational breakup. Some comets show clear cases of it. Atlas tumbled with irregular light. Models suggested rising spin rate. Hubble frames supported this view. Fragments drifted in arcs consistent with torque. Comparisons help explain Comet Shoemaker-Levy 9 fractured before impact with Jupiter. Its pieces fell in long train. Comet Elenin collapsed in 2011, leaving only dust cloud behind. Comet Ison broke near the Sun, its nucleus lost in flare. Each case showed same physics. Fragile cores cannot resist heat and spin. Atlas was larger than many, but size gave no immunity. Mass spread stress as well as strength. Weakness inside matters more than bulk. Observations showed interior porosity. Atlas carried cavities waiting to open. Laboratory experiments confirmed theory. Dust and ice mixtures placed under heat fractured along grain boundaries. Pressure built in sealed chambers until samples split with sharp pop. Spin tests on fragile aggregates showed collapse at low thresholds. What happened in small chambers also happens in space at scale. The death of a comet is process. Not single cause, but chain of forces. Thermal stress primes, sublimation drives, spin completes. Atlas embodied the chain clearly. Scientists mapped fragment paths precisely. Each followed momentum imparted by jets. Some fragments crumbled within days, others lasted weeks before fading. Together they told one story. The comet was unmaking itself under normal physics of survival. This is the science of cometary death. Bodies too fragile for long orbits. Visitors doomed when heat returns. Their demise is expected, yet watching it unfold is rare. Atlas gave this rare chance. Still, the questions linger. Why now? Why so early? Atlas fractured before perihelion. Most survive until closer. Perhaps weakness inside was greater. Perhaps unseen stress waited for spark. The chapter closes on this puzzle. 3i Atlas died as comets die. Yet faster, earlier, sharper. Next chapter will speculate. Perhaps the breakup was not accident. Perhaps fragments carried purpose, seeds cast across interstellar dark. 3i Atlas was breaking. Its core unmade, its dust spread into drifting clouds. Science explained stress, jets, spin, but speculation saw something larger. What if breakup is not only death? What if it is release? Comets carry chemistry older than Earth. Chains of carbon, frozen water, fragments of organics. Within each grain lies memory of systems long vanished. When bodies fracture, these memories scatter. Imagine fragments as seeds, each one small, but each carrying chemistry for growth. Fragments travel across orbits, some fall into planets, some burn in skies, some settle in oceans. Perhaps life owes its spark to such deaths. Not creation in source, but creation in ruin. Each cometary death a sowing, each fragment a seed. 3i Atlas fit this vision. Its body split before our eyes. Its chemistry poured into dark. A field of seeds cast outward, invisible to us, but fertile across time. Speculation widened further. What if interstellar comets are gardeners of the galaxy? They wander, they fracture, they sow, a silent cycle beyond control. Then death is not end, but transformation. 3i Atlas did not vanish, it multiplied. From one body to many, from one orbit to countless paths. Even fragments too small for eyes carry purpose and possibility. Dust falling through atmospheres, chains dissolving in oceans, sparks waiting in silence. The thought is unprovable. Science measures dust and spectra, but philosophy of seeds lingers. Atlas might be both ruin and genesis, death and beginning at once. The chapter closes on that duality. A comet dies, but the sky gains fragments. The next chapter will explore again how telescopes and missions race to capture this sowing in progress. 3i Atlas was breaking apart, its nucleus split into smaller lights, its dust cloud widening with each night. The discovery was not enough. Exploration demanded more. How do we capture death in progress? Ground telescopes beyond long watches, arrays in Chile, Hawaii, Canary skies, all turned to the fading comet. Each exposure stacked hours of faint light, revealing fragments too dim for eyes. Astronomers logged positions with precision, building a map of dispersal across nights. Hubble provided sharpness unmatched. Its cameras caught shards spreading outward, a procession of glowing specks. Every week the count changed. One body became 4, then 8, then haze. Atlas was not single anymore, but constellation of ruin. Exploration was more than images. Spectra carried chemistry of death. Light split into lines, carbon dioxide faint, water almost gone, organics flickering uncertain. Each fragment held different mix, each a chapter in unravelling core. Observatories coordinated worldwide. One station tracked brightness, another tracked dust size, another tracked jet angles. Together they wrote a diary of disintegration. Students built models late into nights. Simulations filled screens with spinning shards, collisions, torques, pressure bursts, each parameter shifted outcome. Some models showed quick collapse, others slow drizzle of dust. The truth lay between, and data guided the guesswork. Citizen astronomers joined the effort. Small telescopes in backyards caught faint streaks from darker skies. Uploads flowed into shared archives. Many hands caught pieces that big machines alone might miss. Exploration also meant rehearsal. Could probes one day catch fragments? Designs imagined swarms of scouts, each tiny, each fast, each carrying traps for dust. If launched in time, they could skim debris, collect memory of the dying body. But Atlas moved too fast. Its window was already closing. By the time missions could fly, the fragments would be gone. Exploration learned limitation again. We can observe, but not yet touch. Still, progress was real. For the first time, a cometary death was documented in detail, not in guess, not in history, but in real time. The archive of data grew vast. Exploration taught another lesson. Death can be studied like life. Endings reveal structure hidden before. Fragments expose interiors. Dust shows chemistry, light curves tell stress patterns. Atlas became a laboratory of collapse. Night after night, teams logged positions and spectra. Day after day, servers filled with fragments of story. The visitor was vanishing, but leaving record. The chapter closes on this image. A network of eyes watching, machines humming, humans waiting. 3i Atlas continued to unmake itself, and exploration captured every breath. The next chapter will turn to philosophy. It will ask why we watch endings and what it means to measure death in the sky. 3i Atlas was breaking apart, its light no longer whole, its body dissolving into fragments. Science mapped the causes. Exploration captured the process. But philosophy asked the deeper question, why do we watch endings? Why do we look toward ruin, toward bodies failing under stress? Perhaps death is mirror. When we watch a comet disintegrate, we see ourselves. Not in chemistry, not in orbit, but in fragility. Stone too can die, ice too can fail. Even wanderers of the void carry limits they cannot outrun. Death is not only absence, it is also revelation. As 3i Atlas broke, hidden interiors became visible. Secrets long sealed in darkness were released into space. From death came knowledge. Philosophy lingers here. Endings create windows. They open what life concealed. They reveal structure. They show history. They scatter legacy. Without ending, there is no revelation. This truth unsettles and comforts. We fear dissolution, yet we depend on it. Our soil comes from death of stars, our oceans from death of ice bodies, even our breath from decay of earlier forms. Atlas joins this pattern. Its fragments return to cosmos, its dust feeds clouds, its chemistry lives beyond itself. So what is death? Not void, but passage. Not loss, but release. The comet's demise is not final silence, but transformation into many voices. We look and we learn, we measure, we record, we wonder, and in doing so we turn death into window, into teacher, into mirror. The chapter closes on reflection. Three-Eye Atlas fades, but its end remains present in thought. The next cycle will begin again with thriller. Headlines will call it celestial suicide, and fear will run ahead of fact. The first cycle has closed. Three-Eye Atlas entered as faint traveller, then fractured before our eyes. Thriller showed the moment of rupture. The nucleus split, the light collapsed, the body no longer won. Science mapped the causes with patience. Thermal stress, sublimation jets, and the slow cruelty of spin tore the comet apart. Speculation looked wider. Perhaps fragments are not ruins, but seeds scattered into dark, carrying chemistry across the void. Exploration followed with urgency. Hubble watched from orbit, mountains tracked from Earth, students modelled collapse on their screens. The death of a comet became record in detail. Philosophy closed this cycle in silence. Death is window, revealing what life conceals, teaching that endings release legacy. The next cycle begins with noise. Headlines will shout celestial suicide. Fear will grow louder than science again. The first notices appeared just before dawn. News anchors read lines without pause. Celestial suicide, one headline claimed. Another scrolled words across the bottom bar. Comet kills itself before our eyes. The choice of language set the tone. What began as science became drama. Clips ran in loops. Time-lapse sequences showed the comet fragmenting. One body became four became a haze of specks, dust clouds trailing into emptiness. To astronomers it was expected. To the public it looked like intent. Each split resembled a countdown. Each dimming step resembled a last breath. Commentators filled air with speculation. They asked if fragments might reach Earth, if dust storms could blot the sky. Officials issued calm replies, no threat, no impact, but fear had already outrun fact. Social media burned like dry grass. One thread spoke of invasion, another declared a warning from stars. Some voices insisted the death was scripted, a sign left by vanished civilizations. Others framed it as omen, a mirror of our own fragility. The word suicide spread faster than light, attaching to every image of fading streaks. Conspiracy channels swelled. Talk show hosts waved shaky graphs. They claimed governments hid truth of danger. They spoke of payloads embedded in debris, of signals timed with fragmentation. A comet became stage for fear. In observatories, the atmosphere was heavy. Screens displayed brightness curves, dust profiles, fragment orbits. The numbers spoke clearly of stress and spin, yet beyond the dome the story was lost. A young assistant scrolled news on her phone. She had spent nights tracing fragments carefully. Her log showed venting jets and thermal cracks, but every headline she saw said otherwise. Celestial suicide, cosmic omen, endgame. She wrote a note in her margin. Truth bends faster than light tonight. Governments felt the weight as well. Emergency councils gathered in capitals, not because of risk, but because of rumour. Markets wavered under uncertainty. Airlines fielded questions about cosmic dust. Insurance firms drafted sudden reports. An object safe in orbit caused fear unsafe on Earth. Public gatherings formed in city squares. Some carried signs that read, "Do not hide the danger." Others prayed under open sky, believing the fragments carried message of end. Children looked upward in confusion. Parents struggled to answer questions. Newsrooms glowed with red urgency. Producers ordered more graphics. They overlaid countdown timers, 5 fragments, then 6, then more. Each number framed a step toward collapse. Data became spectacle. Spectacle became story, stolen story became fear. Scientists tried to intervene. They wrote statements in clear language. They explained the physics patiently, but their words carried little reach. They moved slower than rumour. They spoke softer than panic. Hubble released new images, fragments sharper, tail ragged, core nearly gone. Astronomers described brittle failure, but captions called it self-destruction. Even truth was wrapped in drama. A student group in Chile held vigil at midnight. They watched streaks fade across horizon. One whispered that endings can be beautiful. Another whispered that beauty can be terrifying. Both looked at the same fragments. Both found different meaning. By week's end, the comet was symbol. Not stone, not ice, but myth. Some called it omen of collapse. Some called it mirror of us. Few called it what it was, a fragile body undone by heat. 3i Atlas continued drifting outward, its fragments scattering in silence. On Earth, the silence was broken, replaced with noise of headlines and fear. The chapter closes on glowing screens, words pulsing brighter than data, fear sharper than fact. The next chapter will return to science. It will trace fragments with orbits and light curves to measure truth again through patient eyes. 3i Atlas no longer travelled whole. Its nucleus was shattered, its light reduced to scattered points, but science worked as anchor. If fear grew louder outside, numbers remained steady inside. Teams across continents began their task. They measured every fragment night by night. Positions were logged with patience. Brightness curves were tracked carefully. Orbits were recalculated with new data. The picture grew clearer as nights passed. Fragments followed paths diverging slowly. Some drifted outward at gentle speed. Others curved along tail of dust. None showed signs of collision course. Earth remained far outside the hazard zone. The physics of breakup explained the spread. When a nucleus fractures under stress, pieces inherit momentum of rotation. Some are flung slightly forward, others slightly behind. Each fragment carries pressure of jets. The combined forces scatter them wide. Astronomers modelled this behaviour. Supercomputers drew simulations of rotating rubble. They showed Atlas spinning faster each week. Thermal jets acted as thrusters, spinning body to breaking point. Fragments then tumbled outward along the predicted arcs. The models matched reality with eerie precision. Spectra added another layer. Dust clouds thickened with fine grains. Carbon dioxide lines remained faint. Water was nearly absent. But faint signatures of organics persisted. Though fragile and incomplete, these patterns showed inner chemistry. Atlas was rich in brittle bonds, poor in stabilizing ice. This weakness explained its early death. Hubble confirmed fragment sizes. The largest was no more than a hill. Others were boulders adrift in haze. Smallest were grains invisible to ground scopes. Together they formed a train of ruin, stretching across hundreds of kilometres. Risk and analysis followed quickly on could any fragment cross our orbit. Trajectory plots showed no intersection. The shards would drift harmlessly away, scattering into darkness over years. Reassurance came in quiet graphs, but headlines had already chosen fear. The value of study lay elsewhere. Atlas offered rare chance to learn. Few comets die under watchful eyes. Most vanish near the sun unseen. Here was death unfolding nightly, recorded in exquisite detail. Each orbit trace told a story of stress. Each brightness dip showed release of energy. By mapping fragments, scientists could reconstruct the final collapse. They could measure strength of nucleus, estimate spin at moment of rupture, calculate pressure inside hidden chambers. Laboratories mirrored this work on Earth. Mixtures of dust and ice were spun in vacuum chambers under heat. Samples cracked at predicted thresholds. Fragments flew along similar arcs. Atlas validated these experiments, turning theory into confirmed physics. Students contributed. Science. Programs opened datasets to the world. Amateurs tracked faint points with small scopes, uploaded positions to shared servers. Their numbers filled gaps in global coverage, helping refine orbits with greater precision. In classrooms, the story carried weight. Charts of Atlas fragments hung on walls. Children traced paths with rulers, learning how bodies die in space. Death became lesson. Lesson became memory. By the close of month, the story was written clearly. 3i Atlas had fractured under heat. Spun apart by jets, released dust into trailing arc. Its fragments would never return whole. The comet was gone, but its data remained. Science spoke in calm, steady lines. Death explained by thermal stress and spin, risk dismissed with confidence, knowledge gained in detail. But the world outside still murmured omen. Data does not travel as fast as myth. The chapter closes on this truth. 3i Atlas is gone, but its fragments still instruct. The next chapter will speculate again. Perhaps the breakup was not random, but release of archive long carried, a cosmic capsule scattering itself by design. 3i Atlas broke apart in fragments drifted outward like pages of a book. Science named stress and jets as cause, but speculation asked another question. What if this death was not random? What if it was release? Comets carry chemistry from ancient times, frozen molecules locked since before the sun, dust filled with carbon chains, traces of water ice, organic whispers older than Earth. Each fragment is archive of the past. Imagine Atlas as a vault in motion, its nucleus sealed memory of another system. When stress reached limit, the seal opened, not by accident, but by design of nature, or perhaps by someone older. Fragments scatter like documents in wind. Each shard carries record of conditions long gone. Ratios of isotopes speak of birthplace. Chains of molecules speak of chemistry. The dust is archive, the breakup the release. Some thinkers go further. What if comets are deliberate libraries, vessels launched across stars filled with coded chemistry? Their death becomes distribution. Fragments cast wide, data scattered through galaxies. Perhaps Atlas carried such a record. Not message in words, but message in molecules. Not archive on paper, but archive in bonds. Its breakup then is no failure, but function fulfilled. Others imagine test of time. Only civilizations able to read fragments would unlock meaning inside. To primitive eyes it is only dust. To learned eyes it is memory. Atlas in this view was capsule, opened on schedule of stress. Skeptics remind us of simplicity. Fragile ice does not require purpose. Breakup is physics, not prophecy. But even skeptics admit the image of archive is strong. We want to believe records exist, left for us by distant hands. In this vision, Atlas did not die. It delivered. It scattered its content into space, not lost but shared. The chapter closes on that thought. A comet becomes archive. Death becomes release. Next chapter will turn to exploration. It will ask how we might capture these fragments of memory before they drift into silence. 3i Atlas was already dissolving. Fragments trailed behind in widening veil. Dust streamed outward with every rotation. Science read physics in curves. Speculation imagined archives in shards. Exploration asked a harder question. Could we catch the pieces? Ground telescopes tracked faint lights. They logged positions nightly, but fragments were growing smaller. Within weeks many fared below reach. The larger shards remained a little longer, but they too moved outward fast. Every hour mattered in pursuit. Agencies held late calls across time zones. Could a mission launch in time? Could any probe intercept the train of debris? Designers drafted scenarios quickly. Small scouts with ion engines, solar sails unfolding like glass wings, payloads compressed into cubes, spectrometers miniaturized to fit grams. Some plans were impossible already. Launch windows closed too quickly. Atlas moved beyond reach of rockets, yet ideas were tested for future visitors. Swarm probes that could scatter across sky, collectors made of aerogel, catching dust like falling snow, laboratories in orbit, reading chemistry before decay. Exploration extended to Earth itself. High-altitude aircraft prepared to skim atmosphere, hoping fragments might cross our air. Dust detectors calibrated for faint grains, tiny shards that might fall unseen. Networks of volunteers joined the chase, cleaning filters, logging samples, hoping for one trace of Atlas. Hubble watched from above. Its vision captured sharper images. The orbits of main fragments were mapped, but capturing was beyond its reach. The telescope could only see, not touch. Laboratories built replicas instead. Samples of ice and dust spun and fractured under heat. They watched cavities burst, dust jets scatter, fragments crumble into smaller clouds. Atlas could not be reached, but it could be simulated. Exploration became rehearsal. Not victory now, but preparation. The next interstellar body would come, and humanity must be ready. In classrooms, students built models. They simulated fragments on chalkboards. They dreamed of chasing archives with folded sails. Some argued for stations at Lagrange points, waiting for visitors to pass. Others imagined faster engines, nuclear or fusion drives. The lesson was clear: do not wait until too late. Still, the absence stung. Atlas was here, breaking in sight but unreachable. A library scattering pages in storm, and we could not hold even one. The chapter closes on this ache. Exploration looked, designed, rehearsed, but could not touch. 3i Atlas slipped away regardless. The next chapter will turn to philosophy. It will ask what it means to watch endings we cannot prevent, to see libraries scatter without reading them. 3i Atlas entered our sight as traveller. It left as fragments drifting into dark. Its death was measured in graphs and frames. Its passing was written in headlines and fear, but its meaning was larger than numbers. Impermanence is the rule of sky. Stars swell, burn, collapse. Worlds cool and fade. Comets fracture under light and spin. Nothing endures, not stone, not fire, not us. Watching Atlas reminded us of this truth. Mortality does not belong only to life. Even matter carries limit. Even ice knows failure. Even dust has its end. Yet impermanence is not void. It is also transformation. Atlas became dust, but dust will drift. Fragments will join clouds. Clouds will form new stars, new planets and new oceans. The death of one body feeds the birth of others. Philosophers turn to ancient parallels. In myth, death is release of soul. In science, death is release of memory. The comet scattered its record of chemistry. Its end was its contribution. Impermanence teaches humility. We cling to permanence, yet nothing grants it. Civilizations rise, machines fade, languages vanish, worlds collapse. Still, then, from each ending, something carries forward. A legacy is not avoidance of death. Legacy is what death releases. In classrooms, the message deepened. Students looked at charts of fragments. They traced lines outward and realized that loss is also gift. The comet gave data in breaking. Its ruin taught physics. Its fragments taught chemistry. Its impermanence became lesson. 3i Atlas broke apart, and in doing so, it joined the cycle. To end is not to disappear. To end is to continue differently. The chapter closes on this reflection. Impermanence is not curse but law. We watch ending not to despair, but to learn how they carry seeds. The next cycle will begin again in suspense. Rumours will rise about chaotic fragments, and fear will return of impact. The second cycle is closed. 3i Atlas fractured further. Its death carried through fear, science, speculation, exploration, and thought. Thriller told the story of headlines. Celestial suicide declared screens. Panic spread faster than data. Science returned with a patience. Orbits of fragments mapped, spectra measured chemistry, risk dismissed as safe. Speculation leapt again. Perhaps Atlas was archive, a vault of molecules scattering by design, a library dissolving into dust. Exploration answered with plans, swarm probes, aerogel traps, high-altitude planes searching for grains, but the comet moved too fast, leaving rehearsal for future missions. Philosophy closed the cycle in silence. Impermanence is the rule of sky, death is not void, but transformation, a legacy scattered into night. The next cycle begins with deeper suspense. Rumours will rise of chaotic fragments. Fear of impact will return louder still. The first rumours began in quiet forums. A chart appeared without source, lines crossing Earth orbit, fragments plotted like falling stones. Within hours, the image spread. Some claimed official leak, Others swore astronomers hid danger. The phrase gained weight online. Atlas fragments on collision path. News anchors repeated it without pause. Could pieces strike Earth? Would we face rain of fire? No data confirmed it, but fear no longer needed proof. Crowds gathered again in public squares. Screens displayed animations of impact. Crude simulations showed glowing trails, fireballs tearing across continents. No citations followed, yet the images spread unchallenged. Astronomers tightened their statements. They said orbits were known. They said paths missed by millions of kilometers, but voices drowned in noise. The word chaos grew louder. One graduate student sat in control room. Her log showed calm numbers, angles stable, drift within models. Still, her phone buzzed with messages. Friends asked if fragments would kill them. She typed back with patience. No risk, no danger, but her hands shook all the same. Markets trembled once more. Flights delayed by the rumour of cosmic dust. Insurance rates adjusted overnight. Governments called secret meetings again. Not for impact, but for unrest. Some voices leaned into doom. They called Atlas a warning. They called fragments a test. Every streak in night sky was framed as incoming shard. Observatories faced protests at their yates, accusations of cover-up, demands for truth shouted into night. Scientists inside watched graphs steady, yet outside the air burned with suspicions. Hubble released another series of images, fragments drifting apart calmly, orbits diverging outward, no sign of crossing Earth, but captions online twisted the view, pictures called proof of oncoming storm. The comet itself moved indifferent. Its dust spread like breath. Its pieces faded into haze. But below, fear sharpened again. The chapter closes on this tension. Data calm, public chaos, fragments harmless in sky but dangerous in story. The next chapter will return to science, to trace the mathematics of chaos, and explain why risk remains small even when orbits seem uncertain. 3i Atlas had broken into many lights. Rumours of impact spread, but science turned again to orbits and math. Fragments were tracked across nights, each point logged, each drift measured against models. The result showed scatter, but not danger. When a nucleus splits, each fragment carries momentum. Spin adds torque, jets add thrust, paths diverge, but they remain predictable in short term. Atlas fragments showed this clearly. Some moved faster along the tail, some lagged behind the dust cloud. A few drifted sideways in small arcs, none curved toward Earth. Chaos in celestial mechanics does not mean immediate threat. It means long-term sensitivity. Tiny forces shift paths over centuries, not days. What looks chaotic in diagrams remains safe for now. Astronomers ran Monte Carlo models, thousands of simulations, each with slight variation. All showed same conclusion. No fragment intersected Earth orbit. Probability of collision was near zero. Spectra confirmed low mass in fragments. Dust dominated, large bodies rare. The biggest shard was only hill size, still far too distant to matter. Most would crumble into dust before completing even one orbit. Laboratories compared breakup events, Shoemaker-Levy 9, Elenin, Ison, all followed similar dispersal. Atlas matched the pattern well, fragments dispersed along the train, not across planet paths. The panic outside did not match this. Scientists prepared clear releases. They explained chaos precisely. Uncertainty is real, but scale matters. Uncertainty of meters does not equal threat of impact. One researcher wrote in her notes, "Chaos is not catastrophe, it is sensitivity, and sensitivity is not danger." Hubble continued to map faint shards. Positions updated daily. The sky showed calm diffusion. Pieces faded steadily. Not one grew brighter or closer. Risk assessment concluded firmly. Atlas had died already. Its fragments were dust in training. Its orbit carried no harm. The true impact was social, not celestial. The chapter closes on steady graphs. The lines trace arcs outward. Fading into dark, numbers are calm, fear is noise. The next chapter will turn speculative. Perhaps the breakup was not only archive, but a message timed to self-destruct, a messenger meant to vanish on arrival. 3i Atlas shattered before perihelion. Its body dissolved faster than models expected. Science spoke of thermal stress and spin, but imagination shaped another story. What if this breakup was not weakness? What if it was intention? Imagine a messenger launched long ago. It carried information, chemistry, perhaps memory of its makers, but it was never meant to be caught. It was meant to self-destruct. Fragments then become design, not failure. Each shard carries a fraction of message. Each grain disperses code in molecules. The archive cannot be seized whole. It must be gathered from many pieces, if gathered at all. Such a system protects against capture. No one civilization could own the data. Only those patient enough to piece fragments together could approach meaning. Atlas fits this pattern in speculation. It broke not too close to sun, but early, as if on schedule. The timing looked deliberate. Death as delivery. Others imagine safety by destruction. A messenger might be dangerous intact. It may carry chemistry unstable in bulk. Only by breaking apart does it become safe to spread. The self-destruction is protection. Still others view it as test. A probe that dissolves on entry. Those who watch carefully learn from fragments. Those who wait idly learn nothing. The lesson hides inside collapse. Skeptics answer firmly. Fragile bodies do not need purpose. Physics explains their fall, but speculation lingers, because the timing unsettles, because the death looked early. If Atlas was messenger, then its ruin was its plan, not survival, but dispersal, not presence, but legacy scattered. The chapter closes on this thought. The comet did not die. It executed command. Its message now lies in dust, waiting for readers in skies to come. The next chapter will turn to exploration. It will ask how laboratories and missions can simulate such self-destruction, and what we might learn from the death rehearsed in fragments. 3i Atlas had already vanished into dust, its fragments scattered beyond reach, but laboratories on Earth turned the question inward. If the comet was messenger, if its breakup was deliberate, could we simulate such a death? Teams built fragile models of ice and dust, mixtures pressed into chambers, chilled under vacuum, then exposed to rising heat, cavities formed beneath crust, pressure climbed until surfaces burst, fragments flew across glass walls, sensors traced every arc, the behavior matched what telescopes saw. Next they added rotation, samples spun on delicate mounts, jets erupted from uneven cracks, torque grew with each vent. At a threshold the samples failed, bodies split, pieces drifted outward. This was mechanical echo of what Atlas revealed in space. Exploration scaled experiments upward. Supercomputers modelled kilometre bodies. They varied spin rates, volatile ratios, thermal gradients. In simulation after simulation, patterns of breakup repeated. Atlas was not anomaly, but example of fragile rule. Still the thought of messenger lingered. Could we design such a system ourselves? Probes carrying information, meant to self-destruct after passing. Engineers sketched concepts cautiously. Payloads encoded in dust, released only through fracture, delivery by death. Mission proposals followed this vision. Swarm probes intercepting comets, each catching fragment in aerogel. Onboard labs analysing before decay, others dreamed larger. Space stations at key orbits, waiting to capture libraries of dust. Future telescopes tuned for faint signals, reading archives in spectra. Students contributed with energy. They simulated breakups on chalkboards, mapped fragment paths in detail. They imagined intercept missions, small scouts racing through dust clouds, returning samples in capsules. For them, Atlas was not loss, but challenge. Citizen astronomers joined too. They logged meteor trails on cameras, hoping grains of Atlas might fall. Networks compared streaks nightly. Fragments were too small, yet the vigilance built skill for next visitor. Exploration thus became rehearsal. Each experiment, each model, each design, a way to prepare for future comets. Atlas taught by absence. Its death could not be touched, but it could be recreated. The chapter closes on this vision. A laboratory chamber glowing cold, dust and ice cracking under light. Small fragments drifting across glass. Miniature echo of cosmic ruin. The next chapter will turn to philosophy. It will ask what it means when death itself can be simulated, and if every simulation is mirror of our own impermanence. 3i Atlas was gone from sight. Its fragments faded into darkness. Its trail dissolved across months of data, yet its meaning lingered still. What is death in the cosmos? Not silence, but change. Not void, but transformation. Stars die into remnants. White dwarfs, neutron cores, black holes. Worlds die into frozen husks, their oceans locked, their skies stripped. Comets die into clouds of dust, their chemistry scattered, their shapes erased. Death is never final in space, it is passage, one form yields to another, legacy persists through fragments. Atlas showed this truth with clarity, it arrived whole, it left broken, but in breaking, it revealed its interior. In fragments lay chemistry unsealed, in dust lay records of ancient past. Transformation is paradox, we fear the end, yet we depend on it. Our planet was seeded by ruins of others. Our breath comes from matter recycled. Life thrives because death has scattered gifts. Some philosophers saw Atlas as mirror, a fragile traveller undone by stress, its legacy written not in survival, but in release. Civilizations too may follow this law. We build, we fracture, we scatter our archives. Future watchers may read our fragments as we read Atlas now's. Others wrote of humility. We claim permanence through machines and memory, but a comet reminds us that every body yields to impermanence. Strength is brief, endurance is fragile, transformation is inevitable. In classrooms, the lesson deepened. Children asked why the comet had to die. Teachers answered softly, so we may see what was inside, so the sky may share its memory. Atlas gave us more than spectacle. It gave us reflection. Its death was not void, but mirror. It taught that endings can instruct, that loss can illuminate, that transformation is the law behind all things, and the chapter closes on quiet thought. A comet died, but in death it taught. The next cycle begins again with thriller. Rumours will rise louder, claims of hidden knowledge will spread, the story of death will fracture into secrecy. The third cycle is closed. 3i Atlas was gone, yet its story deepened through fear, science, speculation, exploration and reflection. Thriller spoke of impact rumours. Charts without source spread panic. Protests rose outside observatories. Science corrected with calm graphs. Monte Carlo simulations, spectra of fragments, risk close to zero. Speculation imagined the comet as messenger. A probe designed to self-destruct, its archives scattered by intent, its death a command executed. Exploration turned to simulation. Laboratories cracked ice and dust and spun fragile samples to fracture, rehearsed the lessons of collapse. Philosophy ended in silence. Death is transformation. Endings are mirrors. Atlas taught that impermanence is the law of cosmos and release is legacy. The next cycle begins darker still. Leaks will stir suspicion, claims of hidden knowledge will fracture trust, and the comet's death will echo louder than its life. It began with a single image, a grainy slide surfaced online, stamped confidential in faded letters. The title read Fragment Behavior Assessment. Below, one line burned across screens, possible evidence of engineered breakup. Within minutes the leak spread everywhere. Blogs reposted, forums flared, headlines sharpened, NASA knew. They wrote, Atlas was not natural, its death was controlled. Protests flared outside observatories. Crowds carried signs that read, Tell us the truth, stop the cover-ups, the comet was gone, yet its fragments lived on as rumour. In newsrooms, the tone shifted quickly. Anchors asked if breakup was self-destruction, if archives were scattered on purpose. Commentators speculated about alien messengers. Time capsules timed to fail. Fear turned into anger. Anger turned into suspicion. Inside NASA halls, tension thickened. Some staff swore the phrase was misread, a draft line taken out of context. Others worried careers might fracture like the comet itself. Meetings stretched through the night. Language was passed word by word. Every explanation sounded weaker than the image repeating on screens. A graduate coder scrolled through the leak at her desk. She saw the line engineered breakup. Her data showed thermal stress, jets, spin, but the words unsettled her deeply. She whispered aloud to herself, "What if the comet obeyed command?" Governments joined the uproar. Emergency councils asked for classified briefings. Markets trembled again, not from dust but from doubt. The idea of cover-up carried more weight than physics, and conspiracy channels swelled overnight. They claimed hidden missions chased the fragments. They spoke of archives already captured, of knowledge locked away. No evidence followed, yet the story burned brighter each hour. Meanwhile, 3i Atlas drifted outward, its fragments fading into silence. Indifferent to uproar, indifferent to leaks, the comet carried on while Earth tore itself in suspicions. The chapter closes in silence heavy, not silence of space, but silence of trust broken. Science spoke calm, but the crowd no longer listened. The next chapter will return to science. It will ask what the leak really meant, and test rumour against the sky itself. The slide spread faster than any orbit. Possible evidence of engineered breakup. The words replayed endlessly, but science could not move on rumour. It turned again to sky and data. Independent teams joined across continents. European observatories recalculated orbits of fragments. They found divergence explained by stress and spin, no pattern of control, no sign of deliberate thrust. Japanese telescopes turned to spectrum, carbon dioxide faint, water nearly gone, organic lines fragile but natural, nothing exotic, no engineered propellant hidden in dust. In Chile, infrared arrays mapped thermal hotspots. They saw cavities venting in shifts, jets erupted, then faded as fractures widened. Each burst aligned with the expected stress, not with code or signal. Supercomputers ran simulations again, thousands of trials with slight variation. The match was uncanny. Atlas had broken exactly as fragile bodies should. The rumour of design dissolved in models. Reports circulated quietly. Non-gravitational forces were real, but fully explained by physics. Breakup required no architect, only sunlight, ice, and time. Still, suspicion lingered. The leaked phrase had weight. Engineered breakup echoed louder than technical papers. Crowds repeated it as truth. But among scientists, the conclusion was firm. Atlas died as comets die. One researcher wrote in her margin, "Data closes the door, but rumour leaves it ajar." NASA issued careful statement. "We confirm disintegration. We find no artificial cause," but the statement fell flat. No answer sounded louder than suspicion. Meanwhile, the comet fragments faded, each night weaker, each frame emptier. Soon there would be nothing left to watch. Only memory, only data, only the echo of a rumour. The chapter closes on this paradox, proof complete, yet doubt alive. The next chapter will speculate again. Perhaps the comet was not accident, but message designed to vanish, a letter written to self-erase. 3i Atlas shattered before it reached the sun. Its fragments scattered in silent arcs. Science measured stress and spin, but speculation imagined intention. What if the breakup was not failure? What if it was message designed to vanish? Consider a letter written in fragile ink. It must be read before it fades. Perhaps Atlas was such a letter, crafted to dissolve once delivered. The fragments then are words scattered, each shard a syllable, each dust grain a stroke of script. Together they form meaning, but only briefly before dispersal erases the page. Some imagine it as safeguard. If message was dangerous whole, Breaking ensures it cannot be misused. Knowledge spread wide is harder to hoard. Only fragments remain, each holding part of Steng. Others see test of perception. A vanishing message forces urgency. Observers must read quickly, assemble puzzle before pieces are gone. Those who hesitate lose it forever. Atlas fit this vision. It died earlier than expected, as though timed to fade. Enough fragments visible to intrigue, but not enough to capture complete. A fleeting archive, a transient code. Could molecules themselves be symbols? Ratios of isotopes as numbers? Chains of carbon as letters? Perhaps the message is chemistry, written not in words, but in bonds. Interpreters must seek pattern hidden in spectra of dust. Skeptics argue again for physics. Heat cracks stone, jets fling fragments, spin breaks fragile mass, no design required. Yet even skeptics admit the image of vanishing message is powerful and unbattling. If true, Atlas was not Comet. It was letter unsealed, written by hands unseen, addressed to whoever could read in time. The chapter closes on this image, fragments fading into night, dust, drifting like ink erased, a letter that cannot be reread, a message lost by design. The next chapter will turn to exploration. It will ask if humanity could ever capture such vanishing signals in full, or if all we can do is watch them scatter and disappear. 3i Atlas had already faded. Its fragments dissolved into weak haze. Its supposed message, if any, was lost. But exploration turned toward the future. Could humanity ever intercept vanishing archives in time? Engineers gathered in dim conference rooms. They drew fast sketches on boards. Missions must be agile, ready to launch within months. Heavy rockets were too slow. What we needed were scouts, lightweight and fast, waiting already in orbit. Concept 1 was swarm probes, dozens of tiny craft stored in carriers. When alert arrives of new visitor, the carrier deploys them outward. Each probe small as suitcase, each carrying spectrometer and dust trap. Together they form a net across path, catching grains before they disperse. Concept 2 was orbital stations, placed at Lagrange points, always watching deep space. Armed with telescopes and sample catchers, they could intercept fragments instantly. Permanent eyes on sky, not dependent on launch delays. Concept 3 reached further. Nuclear or fusion drives, craft built for long pursuit. If a comet arrived and began to die, such craft could chase debris for years, gathering samples long after first breakup. Cost was immense, but urgency made it worth debate. Exploration extended to atmosphere as well. Planes fitted with collectors skimmed stratosphere. They searched for fresh grains each season. Networks of balloons added coverage. Filters open to dust unseen. Perhaps one day a vanishing archive would leave trace we could catch here. Citizen scientists joined too. Cameras pointed skyward each night. Automated software flagged new streaks. Fragments too faint for large scopes were sometimes visible in their data. Each contribution built resilience, a wider net against fleeting visitors. Students simulated vanishing archives in labs. They designed chambers where samples disintegrated quickly, forcing observers to read them before loss. Training for urgency became part of curriculum. Atlas had taught that hesitation meant ignorance. Exploration also turned philosophical. Could we ever capture message complete? Or would vanishing always outrun us? Perhaps the only lesson is to prepare, to be faster, to watch closer, to miss less each time. By decade's end, missions were outlined. Solar sails folded in depots, ion engines tested for rapid burn, prototypes of dust collectors flown. Atlas was gone, but it left blueprint of need. The chapter closes on this vision. Launch pads waiting, stations humming at Lagrange, students tracing arcs on chalkboards, humanity preparing for visitors that vanish, hoping next time to intercept before silence. The final chapter will turn to philosophy. It will ask what cometary death means, not in data, not in missions, but in reflection on mortality itself. 3i Atlas is gone now, its fragments dispersed into quiet space, its dust diluted across the void, yet its death lingers, not in brightness, but in meaning. What does it mean when stone can die? What does it mean when ice knows limit? Death is not only for living things, it belongs to matter itself. Stars collapse, worlds freeze, comets fracture, all carry impermanence. Atlas reminds us of this truth. It entered our system whole. It left us cloud and memory. Its death was measured in graphs, but also felt in science. Philosophers write that endings reveal more than beginnings. In death, the comet opened itself, its chemistry scattered, its structure exposed, its legacy released. What we call loss was also revelation. Perhaps this is the deeper lesson. Mortality is not void, it is transformation, from body into fragments, from fragments into dust, from dust into clouds, from clouds into stars again. Death is cycle, not end. And we are part of this cycle too. Civilizations build archives and monuments, yet one day they scatter. What remains is not permanence, but fragments. Fragments may carry memory forward, as Atlas carried chemistry. In this way, the comet is mirror. We see our own fate written in its trail. We too will break, but we too will scatter. But scattering is not Cylinder, it's continuation in another form. 3i Atlas showed us death in progress. Rarely do we witness such an ending unfold. We watched step by step, night by night, until only absence remained. Yet the absence was full of teaching. The chapter closes on unfinished thought. Was Atlas only comet? Was it archive, messenger, or message designed to vanish? We cannot know, but we know this. Its death was not empty. It gave us reflection. It gave us mirror. It gave us reminder that impermanence is the law and transformation the gift. The story ends open, unfinished, like dust still drifting. What comes next may already be here.